Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 29 from the Smith Organic Chemistry textbook. And in this problem, we're asked to treat molecule A, which I've redrawn at the top of the whiteboard here. We're asked to treat it with 5 different reagents or sets of reagents and to draw the products. And so in order to solve this problem, we need to just remember what each of these reagents does and then apply that to this molecule. So A, hydrogen gas and palladium on carbon, is hydrogenation conditions. And so we're going to hydrogenate this double bond. So the double bond is gone. Nothing else about the molecule changes. And so there's the answer to A. B, mCPBA, we're going to epoxidize the double bond in this molecule. And so we're going to get the epoxide here, but because there's not any control using mCPBA, we're going to get both possible epoxides. So we'll get this version where the epoxide is on wedges, and that's going to put the allylic alcohol here on a dash, and then we'll also get the other enantiomer where the epoxide is on a dash and our allylic alcohol is on a wedge. And so that's B. So C is going to be a PCC oxidation. And so pyridinium chlorochromate. So remember, the utility of PCC here is that it prevents the chromium from oxidizing the alcohol all the way up to a carboxylic acid. So it's going to stop at the at the aldehyde stage. So we'll get an aldehyde as our product for C. So then D is going to be chromium trioxide, sulfuric acid, and water. So you may hear this referred to as a Jones oxidation or oxidation using chromic acid, since that's the actual active reagent that we're going to form when we mix chromium trioxide, sulfuric acid, and water. And so, like I was just talking about the use of PCC, the usefulness of PCC is that it prevents oxidation all the way to the carboxylic acid. And so in this case, we're not preventing that oxidation. And so we get oxidation all the way to the carboxylic acid. And so that's going to be our answer for part D. So then for part E, we're asked to use the Sharpless reagent with the plus DET. So this is going to be a Sharpless epoxidation, but I think that we should start by redrawing this as the book likes us to do, so that we have our double bond horizontal, the allylic alcohol to the top right, and then we can fill in the other pieces here. So there we go. And so when it's redrawn like that, and then using the positive Sharpless conditions, the plus Sharpless conditions, what we end up with is the oxygen is going to come from behind or below, depending on how you think of it. And so here's our ring. Okay, and so we're going to have our epoxide on dashed bonds, and that's going to put the allylic alcohol on a wedge like this. Okay, and so there we go. There's the answer to E. Yeah, and so the way to approach this problem, the only way to approach this problem really, is you have to know what each of these reagents does to an alkene or to an alcohol for the oxidations. And then you need to just apply what each of these reagents does to this molecule. And that's the answer to Chapter 12, problem number 29.